So next, I'm going to have the TAs, or the ones who can show up today, introduce themselves. I want to tell you that we're going to make up office hours later this week. Office hours will probably start next week. And you should feel free to use the services of any TA, not just your own lab TA, when you're looking for help. So take it away.
Hey guys, I'm Manish Raghavan. I'm a second-year EECS major, and yeah, I have Thursday mornings 9 to 11 and 7 to 9 p.m.
Say your name again louder, just your first
Manish
name.
Raghavan. Manish.
Manish, thank you.
Hi, my name is Iris, and I'm a third-year CS major, and I teach Fridays labs 11 to 3.
Hey guys, I'm Mona. I'm a fourth-year EECS major. I TA'd this class last year, and I took it a year before that. I teach Thursday 3 to 5 and Friday 4 to 6.
Hi, my name is Pradyum, and I'm a sophomore CS major. I hope all of you really enjoy 61B. Professor Shuchak is just amazing, so I'm sure you have a good time.
Hi, everyone. I'm Joel. I'm actually a PhD student, and I'm not actually teaching section. I'm just doing various administrative tasks for the class.
Hi, I'm Jeff. I'm a fourth-year CS major. I also TA'd this class last year, and my sections are Thursday at 11 and 1.
Hi, I'm Kevin. If you need if you're in my section and you guys had like faulty account forms, come get them from me.
Hi, I'm Eric. I'm a third-year EECS major, and I teach Thursdays 3 to 5 and Friday 1 to 3.
I'm also Eric, but with a C. So I'm a second-year EECS major. And then I have a quick announcement. So last summer, I interned at an educational software startup called LearnStreet. And currently, LearnStreet is offering their brand new Java for Dummies course, which is a $60 value for free to Cal students. The founder is a Cal alumni, and he really wants to get your feedback on the class. So LearnStreet's new course is a great way to pick up the basics of Java. So the offer will expire 2 Mondays from now, February 10th. So to claim it, use the link learnstreet.com/caljava or check it out on Piazza. I made a post there as well.
Thanks, Eric. Hi, everyone. I'm Evan, and I'm really excited to help teach this class.
Hi, everyone. I'm Caleb. I teach lab on Thursdays from 5 to 9 p.m.
Hi, my name is Brian. I came on stage because I wasn't sure if you could see all the TAs on the side, but this is my second time TAing for Professor Shuchak, so I'm really looking forward to teaching this class. Thank you.
Thanks. Thank you all. Another quick announcement, the Computer Science Undergrad Association, or CSUA for short, is kind enough that they are going to hold a Unix Vim help session tomorrow at 6 p.m. in 306 Soda Hall. If you don't have beginning Unix skills, the basic ability to do the Unix things you need to do for this course, which may be the case if you took E7 as a prerequisite instead of 61A, then please attend this help session tomorrow. They'll get you up to speed so that you can do your labs and homeworks easily. And onward into classes. How do you define classes of your own in Java? So you might recall me telling you, yeah, question. I don't know if there will be a health section on Emacs. This is the only one that CSUA told me about. Any CSUA people here who know? All right, I'll try to find out. You might recall me saying on Monday that an object is a repository of data. When you define a class of objects, you need to say what kind of data you want to store in that object. And so the basic mechanism for doing that is called fields. The fields of a class. And fields are variables, places to store things in memory, that are specifically stored in objects, as opposed to local variables, which are not stored in objects. So every object, or almost every object, has fields where you can store things. Fields are also known as instance variables. And that distinguishes them from the local variables that you declare in a method and from something else called class variables that I'll tell you about half an hour from now. In Java, fields are addressed a lot like methods are. The way you can tell the difference is that a field does not have parentheses after it. A method always has parentheses after it. So for instance, suppose that I have a class of human objects, and Amanda is a human object, then Amanda.age. When you see something like this written in Java with no parentheses after it, that is a field. And on the other hand, if I write Amanda.introduce with parentheses after it, then that is a method call. And you can always tell the difference that way in Java. This is not true of all languages. Those of you who have experience with C++ know that you can't always count on this distinction, but in Java you can. So what I want to do now is I want to write a class definition for human objects. So you might want to make a whole page available for this, because I'm going to be adding methods to this class throughout this lecture. But here's what a class definition looks like. I start with the Java keyword class, which says, I'm declaring a class now, and I name the class human, and then an open parenthesis, and inside the parentheses, or the braces, pardon me, inside the braces I'm going to have all of the fields that a human stores, and all of the methods that you can call on a human. So let's give it some fields. I'm actually going to leave a little room here for an extra field that I'm going to add later. You might want to leave a little space there. But here's a few other fields we're going to use. We want every human to have an age. So inside the human class, I have a line that declares every human has an age of type int, meaning an integer, and it's public. I'll talk about that more in later lectures, but public means other classes can read that age. And I want every human to have a name too. So I will declare a field of type string called name. And so that's pretty much the fields that I need for now. Then I want to write some methods that do things with those fields. So for instance, I might have a method called introduce that allows the human to introduce itself. And what we're going to do is we're going to use our standard way of printing things, which is you take the object system.out and you call the print line routine on it, as some of you have already done for homework 1. And here's a string to print. We're going to build it up by concatenating a bunch of strings together. All right, so to close off this class now, I would put one more closing brace at the very end, but I'm not actually going to do that, and the reason I'm not going to do that yet is because, again, throughout this lecture, I'm going to add a bunch more methods like this method to this class. So you might want to leave the rest of this page in your notes blank so you have room to add the new classes as we collect them throughout the lecture. But everything that's inside this class human, right up to the closing brace, that is called a class definition. And inside that class definition, I have several field declarations, field variable declarations, and I also have what's called a method definition. Which starts public void introduce and ends with a closing brace. Question? I have not written a main method for this class, no. So I could add a main method to this class so that we could run the human class, or maybe humans might just be there for other programs to use and call. Human doesn't have to have a main method itself if some other program is using it. Yes? I'm sorry, can you speak louder, please? If you don't do what? Oh, if you don't declare the fields, then you can't use them. So, is that your question, or? If you say they're private, then the human class cannot use, the human class can still use those fields, but other classes cannot use those fields if you declare them private instead of public. I'll talk about that in another lecture. Other questions? All right, so a few bottom line facts are that, of course, each human object can have a different value of age and name. And so now that I've got this class defined, let's use it. I'm going to write a few lines of code that do something with this class. I'm going to start by constructing a human object. So now that I've defined the human class, I can call the human constructor, which exists implicitly, and that just creates an empty human object, which we will call Amanda. And Amanda is my niece, so I guess this constructor is my brother getting busy. And Amanda is 6 years old. And let's give her her name. Getting ahead of myself here. And now that we've constructed Amanda, we will have her introduce herself by calling that method we wrote. And before I show you what that method call does, let's look at what the first three lines do. So the very first line, as I said, creates a brand new human object. with an age field and a name field. And initially, those are essentially empty or blank or zero or null. And we assign them to a brand new variable that we've just declared called Amanda. And so now Amanda is a reference to that new object we've just created. That's what the first line of code here does. The second line of code stores the number 6 in the age box. The third line of code creates a new string object that says Amanda. And stores a reference to that string object in the box labeled name. All right, so now that we've got those first 3 lines executed and we've done all the initializing we want to do to our object, now we can call the introduce method, and the introduce method will write out the following string. I'm Amanda, and I'm 6 years old. Question? Why don't I have the age box as a reference to another box with a number 6? The reason for that is that there's a really fundamental difference in Java between the int type and the string type. String is a class of objects. Int is not a class of objects. Int is something called a primitive type, which means that Java represents it in the most simple, basic way possible without actually creating an object. There are integer objects. That's the integer class with a capital I, and we will use them sometimes this semester. But the simplest, most memory efficient way to store an integer is just as a primitive type called int. And it looks like that, just a 6 in the box. All right, so let's come back and look at the class definition that printed this string. So here we have this introduce method, and you'll notice that when I wrote name here, I just wrote name. I did not write Amanda.name. And when I wrote age here, I just wrote age. I did not have to write Amanda.age. Why not? Well, when I call Amanda.introduce, I hate when this does this. All right, back here. When I write Amanda.introduce, it is calling the introduce method on a specific object. So you just don't just call introduce by itself like you would in Pascal or C. You call it on a particular object, which is Amanda. And so Amanda is implicitly passed to the introduce method. So then inside the human class, when you get to this is it stuck in this mode? It may be stuck in this mode. Is it healed yet? Yes. So when I go and say age, that's implicitly Amanda.age. The Java knows that this method is being called on Amanda, so it uses Amanda.age and not somebody else's age. But sometimes in a class, you want to be able to mix objects. You want to be able to deal with more than one human object at the same time, not just the one we called it on, namely Amanda, but somebody else too. And you can do that. Java gives you ways to do that. But sometimes you have to explicitly specify someone's name. So for instance, here's a method called copy that's going to copy all the fields from one human to another. So the idea is I'm now passing in a parameter, original, which is the original human that I want to copy. And I'm going to copy the fields from the original human to this human, the one that I've actually called copy on. And so I can do that by writing age equals original.age. And likewise copy the name. And so if in some other part of my program, or maybe even in some other class, I might write the following line of code. Amanda.copy Rishi. So that line of code, again, that line of code is not in this class, it's in some other class, somewhere far away in some other method. But when you invoke this method, amanda.copyRishi, it will take the fields of Rishi, Rishi's name and age, and copy them into Amanda's name and age, overwriting the old values. Questions about that? Yeah. Yes. So you have to declare when you take original as a parameter, you have to declare that that will always be a human object, yes. Mm-hmm. I'll show you how to do that in a minute, but you need to write a new constructor to do that. So the question was whether we could break down initializing Amanda to one line, and we'll see how to do that in a minute or so. Mm-hmm. Why don't we use the keyword what? Self. Java has a different keyword, which is this, that means the same thing as self does in, is it Python that uses self? Yeah. So you can do that. You can say this dot age equals original dot age, and it will do exactly the same thing. And I'll give another example of that in a minute. Yes? Why don't I declare... Are you talking about in the original class definition? In the method definition. So the method introduce, you mean? Or do you mean the method copy? Okay. So in the copy method, what I want to do is I want to take two humans and transfer fields from one to the other. So copy doesn't need to know, or doesn't need to be told again that age is an int or that name is a string, because it already knows that from the original class definition. And so those can't change. Int will always be an age, and name will always be a string inside humans. So I can leave that. I don't have to repeat myself, basically. I can just say, original is a human, and that tells us everything we need to know. Mm-hmm. Yeah?
What would happen if you tried to reassign the name age? Could you overwrite an instance variable with, like, a method variable?
Oh, do you mean can you have a method called age?
No. Say within the method copy,
Mm-hmm.
if you had int age equals
Oh,
6 or
I'll do an example of that next. Well, I'll do an example of that soon, so you'll see that in a few minutes. I will come to that. Let me get there indirectly, though. So it is coming up. I want to do some constructors now. So let's write a constructor that actually constructs a human in this human class. So this is how you start writing a constructor. I say public human, and then the parameters that I want to take. And you'll notice that the format is a little interesting here in that, first of all, the constructor that constructs a human is always called human. Constructors have to have the same name as their class. And you'll notice I did not write a return value like void or int. And a constructor always returns an object of that class. So this constructor is called human, and it returns a human. Java, since it always forces you to do those two things, we only have to write human once instead of writing human twice. If we're using the normal format of the other methods, we would say public human, human string, because it's called human and it returns a human. But because Java requires constructors to always have the same name and return the same class, they only require you to write it once. So, public human, and we take a string, and in this particular case, I'm just going to have this constructor always set the age to 6, but it'll set the name equal to whatever the input parameter is, just for variety. So now that I've got this constructor that does a lot of the work for me, I can take the initialization I showed you before, these 3 lines of code here, and I can replace them with one single line of code that does the same thing. And so that one line of code there, human Amanda equals new human Amanda, does exactly the same thing, gives you exactly the same result as those 3 lines of code I just scratched out. Now, one thing you might ask is, before we ever wrote a constructor, why did this line of code here, why did that line of code work? How is it that we were able to construct a new human when we hadn't written a constructor yet? And the answer is that whenever you create a new class but don't write a constructor, Java gives you automatically a default constructor with no parameters. So the default constructor, if you choose to use it for your class, is always one that takes no parameters, and it does no initializing, which really means everything gets initialized to 0 or null or blank or whatever the corresponding null is. So although you don't have to write the default constructor out explicitly, if you did, it would look like this. So that's what Java saves you from typing that out. Yeah. Is it replaced? Oh, it's not polymorphic. Every constructor for a class is for that class only and not I guess it is polymorphic in the sense that its subclasses will always call the superclass constructor. But we'll talk about that when we talk about inheritance. So, yes? If you use the default constructor, then age will be 0, name will be null, which means it does not point to a string. Mhm. Correct. So the question is, after we define our constructor, can we no longer use the default constructor? And that's correct. If you write a constructor, the default constructor goes away. So you only get the default constructor if you don't write a constructor at all. Sometimes you want the default constructor and another constructor. If you do, then you have to write out the default constructor explicitly like this. So I could add this to the human class along with the other constructor I wrote, and then I'd have 2 constructors. Or I can write as many constructors as I want. But if I write one, the default constructor goes away unless I bring it back by writing it out explicitly. Mm-hmm. Constructors, yeah, you don't call them on objects because there is indeed a different syntax for them. So, yes, you can never call a constructor on an object. To call a constructor, you have to use this syntax here, which includes the new keyword. But you can never call human on an object. Yeah. Java decides, so the question is, how does Java decide which constructor to use? It looks at the parameters that you're passing in, and it looks for a match. And then it uses the one that matches. By the way, you can override the default constructor if you don't like it by writing this and then putting stuff inside the brackets. So you want to override it? Then write out the constructor explicitly like this and throw in whatever you want it to do. So I can explicitly say age equals 0, name equals untitled, and that'll be my default constructor now. And next I want to talk about the this keyword. So when you do a method invocation, like Amanda.introduce, you are implicitly passing Amanda as a parameter. And the parameter is called this. So in essence, when I write Amanda.introduce, I am passing Amanda as a parameter, but it's not an ordinary parameter, it's a special parameter. It's the parameter the method is being called on. And implicitly, there's going to be a local variable when you call the method called this. And so I could, for instance, have written this method to say this.age, this.name, and it would do exactly the same thing. In fact, when I write age equals 0, that's really just shorthand for this.age equals 0. And when I write name equals untitled, that's really just shorthand for this.name equals untitled. So coming back to, remember the example of this code here. Well, when this code is running, there's a local variable that's called this. Sorry, when the introduce code is running, when we call the introduce code, this Amanda.introduce, then there are local variables for the method introduce that include this which gets a copy of Amanda. So the reference that is in the Amanda box gets copied by Java into a box called this, which is a local variable of the introduce method. And the introduce method, you recall, also has a couple of other local variables called age and name. So those are the parameters and local variables of that method. Let me give another example. I'm going to add another method to the class now. This method is called change. And to make things confusing, I'm going to have a parameter called age and a local variable called name. So now I have two things called age and two things called name. That's kind of confusing. But if you just say age, the local variable will have priority over the field. So if you want to access the field, you have to use this now. So if I want to assign the field age to the value of the input parameter age, I have to write this dot age equals age in order to distinguish one age from the other age. The field age on the left, the local variable on the right, and the same thing for the name field. Question? You're asking why I have to declare it, or are you asking why it has the same name? Yes, the variable I'm declaring name is different from the field, absolutely. And you know, it's kind of dumb of me to give it the same name, but I'm just telling you how to handle things if that ever happens. So let's suppose I take this change method, and now I write Amanda.change 11 in some other place, some other class or some other method calls the change method like this. Then once again, the change method is going to have local variables. This is going to be a pointer to the Amanda object, and age is going to have 11 because that's what I passed in as a parameter, and name is going to point to a string called Tom. And then the change method does two things. It copies the local variable age into this dot age, replacing the 6 with an 11. And it copies the local variable name into the field this dot name. So this dot name no longer points to Amanda, and it points to Tom instead. And that's what the change method does. here's a very important piece of information, so I'm putting a box around it. You can never change the value of this. If you try to write an assignment statement, something that says this equals something else, doesn't matter what the something else is, Java will never let you do it. You will always get a compile time error. Java just doesn't let you assign anything to this ever. Yeah. Inside the copy method. The change method, okay. Inside the change method, are you asking, you're saying why I had to do this? Well, I didn't, oh, you mean, why do I have to say string? This is a local variable. It's a new local variable. It's not referring to the pre-existing field. So this is something brand new. Even though it happens to have the same name as the field name, it's nothing to do with it at all. It's something completely brand new. And by declaring it as a string, I make it something brand new. Yes, ma'am. Right. If I had left out the word string, this would do something completely different, which is it would take the field name and change it so that it now points to the string Tom. Yep. Mm-hmm. Yeah, you can change local variables including parameters. So original you can change anytime you want. Mm-hmm. Yes? You cannot access the Amanda string object anymore using the from Amanda. No, it's lost. You no longer have a connection to it. Question? If you make a new variable int, another age variable, basically the same thing. So, well, no. I actually cannot say int age here because I've already got an int age there. Parameters and local variables are kind of the same thing. Like every parameter is a local variable, and I can't have two local variables with the same name. So I can have a field called age and a local variable called age, but I cannot have two local variables called age. If I try, compiler error. Mm-hmm. Okay. I'm going to go on now because we're running short on time, sorry, but I want to get through this last page of stuff while there's still time. There's one more keyword we need to learn today, which is static. A static field is a field, but it's a different kind of field. So I can declare a static field, which there isn't a separate copy of it for every human. Rather, there's just one of it, and it's shared by all the humans and has the same value for all the humans. And so static variables are also called class variables. So here's an example of how you write a class variable in the human class. I left a little space at the top of the human class to put a static variable. And this static variable is going to be called number of humans. The purpose of number of humans is to count how many human objects I have constructed. Therefore, it does not make sense that there should be a separate number of humans variable for each human. It makes sense that there should just be one number of humans variable shared by all the humans. So now that we've got that field, let's write a method that updates it. So what I want to do actually is come back to the constructor. I want to add one extra line of code to all the constructors so that whenever I construct a human, I increment the number of humans by 1. So that line of code is the same as writing number of humans equals number of humans plus 1, but it's a bit shorter. And so that reminds us that the number of humans that exist is 1 more than it was before. Now, once we've got that, if I want to look at the number of humans from another class, I can do that as follows. So here's my way of estimating how many children there are. Divide the number of humans by 4. And again, I'm assuming that this line of code is in some other class, which is why I need to put human in front of number of humans. I could also write Amanda.number of humans, and that would work in Java, but that would be misleading, so it's considered bad style, because number of humans has nothing to do with Amanda specifically. It's shared by the whole humans class. Other examples of static fields that you've already seen are system.in and system.out. So that's static fields. Methods can be static too. A static method is one that does not implicitly pass an object as a parameter. So, for instance, I might declare a static method whose job is to print the number of humans. So imagine that this method here is in the humans class. And the reason we declare this method static is because it doesn't operate on any particular human. All it does is print out one static field that's shared by all the humans. So there's no need to pass a particular object to this method or call this method on a particular object. And you've seen another example of a class that's always static. The main method is always static because when you run a program, there is no object in existence yet to pass into that program. And once again, I have an important message about something the Java compiler will never let you do, which is use this at all. So in a static method, there is no this. If you try to use this at all, you get a compile time error. If there are any final questions, then I request you meet backstage so that you're not impeding the next class. And I'll see you all on Wednesday.